Welcome to
MathPractice number 195.
Math Practice number 195. Today we're going to work on Fibonacci numbers a little bit more. And I introduced some notation yesterday just to show you how the Fibonacci numbers work. Fn plus 1 equals Fn plus Fn minus 1. So that means to get the next Fibonacci number, you add the prior two.
Yeah.
And you remember what we start with to get the Fibonacci numbers?
Well, we start with 0.
0.
And 1.
And then 1. And how do they go?
And 1, 2, 3, 5, 8, and so on.
Okay, great. 8 plus 5 would be 13. That would be the next one.
Yeah.
Okay, but what I said yesterday is you don't actually have to start with 0 and 1. So why don't you pick two numbers to start with?
How about 2 and 5?
Okay. 2. Here, let's make a good 2. 2. Good 2, actually. Wow, good job. 5. 7. 12.
And also is 19.
12 plus 19 is what?
That's 31.
31. 19 plus 31 is?
Is 50.
Should we name these? What should we name this sequence? Should we name it after our dog?
The Tink sequence.
The Tink sequence. Okay, what's 31 plus 50?
81.
81. Well, that's a pretty interesting sequence,
Yeah.
don't you think?
Yeah.
Okay. So you can actually start with any two numbers. It's special if you start with 0 and 1. But there's another sequence that's called the Lucas numbers that starts, instead with 0 and 1, it starts with 2 and 1. Because you know what would happen if you started with 1, 1?
2.
You'd get the Fibonacci numbers again.
Yeah.
Okay, so instead of starting with 1, 1, we're going to start with 2 and 1. And let's see what we get. 2, 1, and then what's the next one?
3.
3. What's the next one?
4. 7.
7.
11.
11.
18.
18.
11 plus 18 is 29.
29. Okay, we can stop there. So we have some interesting, we have the Fibonacci numbers and we have the Lucas numbers. The Fibonacci numbers go 1, 1, 2, 3, 5, 8, 13. And the Lucas numbers go 2, 1, 3, 4, 7, 11, 18. Well, that's kind of interesting.
Yeah.
I wonder if we can see any relationships between these two sequences.
Well, these two, it only works for these 4 numbers, but these numbers are 1 greater.
Oh, they are 1 greater. Okay, and this one's 2 greater, this one's 3 greater, this one's 5 greater. That's interesting. So,
I think I see a pattern.
Yeah.
1, 1, 2, 3, 5.
oh, interesting. So this one's 1 greater, this one's 1 greater, this one's 2 greater, this one's 3 greater, that one's 5 greater. What does that remind you of?
Fibonacci.
Whoa, that's pretty neat. Okay. Let's see if we can find some other patterns.
Well, this one's also 1 greater.
How about, you want to see a neat one?
Okay.
How about if I multiply? What if I multiply a Fibonacci number and a Lucas number? So if I go 1 times 3, I get
3
1 times 2 is?
is 2.
What's the difference between 3 and 2?
1.
Okay. What if I do it here? 2 and 4 and 3 and 3?
3 times 3 is 9. And 2. And
2 times 4 is?
8.
What's the difference?
1.
3 times 7 is?
21.
4 times 5 is?
It's 20.
What's the difference?
1.
5 times 11 is?
It's 55.
Good. What's 7 times 8?
It's 56.
What's the difference?
1.
Whoa!
Cool.
Cool. 8 times 18. Well, let's see. That would be 80. What's 8 times 8?
8 times 8 is is 64.
Okay, so that's 144, 8 times 18, and then 11 times 13 is 130 plus 13, which is 143. Hey,
1.
that's pretty neat. The difference always, when I do this funny back and forth multiplication, I always seem to get a difference of 1.
Yeah, and these are all time signs.
They are all the time signs, you're right. So that's pretty neat. So the Fibonacci sequence and the Lucas sequence are actually pretty closely related to each other. Pretty neat, right?
Yeah.
All right. High five, sweetie. That was actually really fun, wasn't it?
Yeah.
All right, maybe tomorrow we'll take a look at the Fibonacci spiral.